Welcome to the video training series, Realistic 3D Character Development using Softimage 3D. This is part 1, Realistic Character Modeling and Texture Mapping, of a two-part series. My name is Chris Marafi, and I will be demonstrating these techniques to you using Softimage 3D version 3.8 SP1, running on an Intergraph system. We will be concentrating on using all spline-based geometry, such as patches and NURBS, to create our characters in these demonstrations. So the first thing I want to do is review the basic strengths and weaknesses of these surface types. Now here you see I have two spheres. One is a polygon sphere and the other one is a spline-based sphere. Spline-based means exactly how it sounds. This is made of individual splines. If we go to Get Primitive Sphere, we can see that there are two spline-based surface types in Softimage. We have patches and we have NURBS. Under these we have linear, cardinal, and B-spline patches and linear, quadratic, and cubic NURBS. Each of these is a little different. B-spline and cubic are the smoothest curves. Cardinal and quadratic are a little tighter curves, and linear are linear. Now if you look at these two spheres, you notice that the polygon looks kind of stair-stepped on the edge, even though they both have the same number of points and subdivisions. This is one of the strengths of spline-based surfaces, is that you can get a smooth surface interpolation with less points. This is going to make you move faster in your interface, as opposed to having a polygon. If you wanted this kind of smoothness, you would have to subdivide it heavily, which is going to bog your system down. The other strength of a patch or NURB surface is that you have variable surface resolution. You can change it by going to Info Selection and changing the step size. By making it a higher number, you can get a smoother object, or a lower number to make less resolution or less subdivisions. Another strength is that when you're deforming with skeletons, patches and NURBS tend to deform smoother than polygon surfaces, which tend to have some shearing which goes on. It's also easier to weight points. Lastly, when you're texture mapping, you can put true UV texture maps on a spline-based surface, where on a polygon surface you have to convert it to UV. Spline-based surfaces do have some limitations though. One of the limitations is that a spline-based surface will always unwrap to be some kind of a rectangle. Whether it's a torus or whether it's a torso, it's always going to unwrap to some kind of a rectangle. And this is represented by the U and V of the surface, which you can see by the red and the green lines. The red is the U, the green is the V, and it shows you which direction these surfaces are going here. So you have to keep this in mind, that by nature a spline-based surface has to stay continuous. If you can't delete a single point on it, you have to delete an entire row in either the U or the V, or add an entire row in the U and the V. It has to come out to be some kind of a rectangle. Polygon surfaces, you can get a complete character out of a single polygon mesh, because you can duplicate, select individual polygonal faces, duplicate them, move them around. You can't do that on a patch or NURB surface. You can't do true booleans on the patch or NURB surface either. Not in the sense that the points will reflect the hole in the surface. You can do a projection or a trim on a NURB surface, but these don't cut a true hole in the surface. So you have to keep all of these strengths and limitations of patch and NURB surfaces in mind when you begin to model your character. Now that we've seen some of the strengths and weaknesses of patch and NURB surface, let's see how we can combine them and move the edge flags around if we need to. In this case, we have a simple head and torso combination, and what we want to do is we want to combine them at the neck, or merge them at the neck. Now you can only merge two spline-based surfaces where the open edges are, or the edge flags are, and the edge flags need to be lined up and going in the same direction. So in this case, if we look at the torso, we can see that the V is starting at the neck and going down. And on the head, it's starting at the neck and going up, which is in the opposite direction. We can also look in the top view and see that the U is going counterclockwise on the head, and it's going clockwise on the torso. So we want to adjust this, and we're going to use curve controls. So you want to go to Model, Effect, Curve Controls, and the first thing I'm going to do is inverse the V. Now if you notice, in the perspective view, we can see that this also inversed the surface. This is different than inversing the V, but we want to inverse that surface back again, so I'm going to do an Effect Inverse. In this particular case, it had the effect of also inversing the U. Now if we look at these two surfaces, the V is going in the correct direction on both of them. It's starting at the top and going down. And also on the U, you can see that it's going clockwise on the head and going clockwise on the torso. So all this is correct. The only thing we have to do is we have to shift the U so it lines up with the U on the other surface. So I'm going to go back to Effect Curve Controls, and I'm going to shift the U so that it lines up with the torso. Now with both of these lined up, I can merge the two surfaces. So what I'm going to do is zoom in close so that I can pick the open edges of these two surfaces that I want to merge. I'm going to use Draw, Merge Surfaces, and then I'm going to click on each of the open edges. Now these are NURBS surfaces, and you can see that I have several choices for blending these two surfaces together. I can use one of the smooth blends or a linear blend. I can also factor the two ends, or I can join the second to the first. You also have different parameters that you can adjust for each one of these blends. So I'm just going to choose one of them, one of the smoother ones, and say OK. I can always tag points and either delete rows or move rows around if they don't quite look smooth to me. Now the smutsy stuff that you can see is the original objects sitting on top of the new object. So I'm just going to delete the original ones. And you can see that my surfaces are inverse, so I'm going to do an Effect Inverse on it. Then if you want to go in and adjust this, it looks like I'm getting some points overlapping each other. I'm going to delete a row of points here and here. And that's going to give me a fairly smooth blend. I can also tag points and move them around to smooth it out further. But these are now a continuous surface. Now that we have this merged together, we want to deal with the arms. And the problem with a patch or NURB surface is you can't really merge arms onto a closed patch edge like this. We could try, if we wanted to tag points here and pull arms out of this surface. But the problem is, if we try to do this, even if we go and add points on this surface, we're going to run into problems with the way that these points are going to be added here. The arms are not going to bend correctly because you don't have the kind of up and down subdivisions that you would be required to get a proper deformation in the elbow and the shoulder by pulling out the arms in this manner. In this example, we have a torso which has the poles on each side where the arms are, rather than the poles at the top and the bottom. Now, The poles at the top and the bottom were good for merging the head to the torso. Well, with the poles on the side here, it's better for merging the arms to the torso. In this case, we would do the same thing as we did before to adjust the edge flags so they lined up with each arm and merge them together. First we would merge one arm, then we would merge the other arm. We would end up getting a continuous surface like this, which looks good. The problem is with the neck and the bottom of the torso. If we go and tag points and translate them down in order to create an area down here for the stomach area and ribs area, we're going to end up getting a lot of pulling, and the subdivisions again are not going to go in the correct way to get a good bending when the torso tries to bend over, nor are you going to get very good bending in the neck up here. So in each of these cases, you're seeing that it's easy to merge in one direction, but to merge in all four directions is very difficult, or in this case impossible, and so it's got to be done in some other way. You've got to make it appear to be one surface, except that it isn't. It's all separate surfaces which have been placed in such a way that the seams are not noticeable. The last thing I want to talk about in this section is gathering reference for your characters. You're going to need front, three-quarter, and side view headshots, either through sketches or photographs for your character designs. You're also going to need photographic reference for various things like textures and modeling. Some resources you can find reference material is in magazines, anatomy books, or the best is to shoot your own reference using a camera or video camera. If you can sketch, you should do character design sketches of your characters. The first and perhaps the easiest method we are going to use for creating a head is called the pull inside the mouth method. Here we have the head of Igor the wrestler, who was created using this method. If we select him, I have a grid texture map on him. You can see that how the surface is moving. It's coming out from the mouth and then going around to the back of the head. If we go up and turn off enable hardware texture and turn on show icons, you can see the edge flags for Igor, and you can see that the V is starting at the back of the head and going into the mouth on the other side, and the U is going straight down the center of the face to the back of the head. Now this method makes a good mouth and is good for characters that are going to be doing lip syncing, but it's a little difficult to make good eyes due to the way the splines are fanning out from the mouth. So we're going to fix that later on by using patches on top of these eyes. There are two ways you can begin modeling with this method. Here I've got a cardinal circle. I use cardinal because the points are on the curve, which makes it a little easier to see. And I've duplicated this circle several times, and as it gets further away, I've modeled it so that it looks like the shape of a mouth just by pulling points using the M key or tagging points. And then I'm going back up and out to a final circle. All of them have the same number of points. So then after I do that, I'm just going to skin them. So I'm going to do a surface skin, click on each one of these in order, and then I'm going to make it a cardinal patch, step of 3, and say OK. Now here you can see that we've got a mouth to start with, and from there I can start building this surface. So this is one way to start. From here I'm going to build this face gradually by adding points as I need them, going from a very simple surface to a complex surface. You also might want to put clipping plane in the front view on so we don't see these back points here. So I'm going to go and I'm going to count the number of grid spaces in the top view. It looks like 1.6 in the Z, and say OK, so I get rid of those overlapping here in the front view around the mouth. Then what I want to do is I want to just start pulling points. And you can use the M key if you want. I'm going to start pulling out a nose. And you want to, if you might want to tag points. And you're going to need to add points. You might also want to put edit proportional on for certain things when you're pulling points. You can use one of the exponentials to get a fall off when you're pulling them, and you want to base it on the grid distance, or so how big your object is going to make a difference. In this case my object is pretty small, so I'm just going to use like 0.5. Okay, so you can continue with this until you get a nice looking face, and the advantage of this is that you build the face gradually, so you really get to see how the points are interacting with each other and see the continuity between the points. The second way to start this method is to get a sphere and rotate it so that the poles are in the front and the back. Then what you can do is you can tag points and translate them in Z, and then you want to shape out a mouth. Now this is also a cardinal sphere, which is cardinal surfaces are a little tighter on the points. Now with a sphere like this, you're going to definitely need to put some clipping planes on in the front view. Then you're going to want to add points. Okay, so here we have the head coming along as I'm slowly sculpting it into the shape of a face. This is a good way for beginners to start out because they can really see how the curves are going to create the nose and other features on the face. When you're done sculpting, you should have a head which looks something like this. Now what we have to do is concentrate on adding a patch for the eyes and some ears later on. To create a patch for the eye in the front view, I'm going to draw a curve. In this case, I'm using a NURBS curve. And then I'm going to do a surface revolution in the y-axis as a quadratic NURBS curve. After you do your revolution, you're going to get a shape something like this. I've pulled points here to make it a little bit more into an eye shape and scaled it a little bit. And after you get it exactly the way you want it, you want to go surface deform it onto your head. So I'm going to do a deformation by surface, node, create, and click on the head. Now, when you deform something on a surface, it tends to go all over the place. What you want to do is scale it in the two directions of that surface, which are the X and the Z, are the main ones. You want to translate it in X. And Z. And you actually have to move the cursor in these directions in order for it to work well. And we'll scale it a little bit in X, and we'll scale it a little bit in Z too. So once you get that to where you want it, you're going to want to freeze that off of the deformation and just pull points to get it exactly the way you want it. So I'm going to do a deformation by surface, node, and freeze. Once you've frozen the eye patch, you want to zoom in on it, tag points, and use proportional modeling to adjust it so that it fits perfectly. Then, once you get it the way you like it, you want to go to texture and put a 2D local or global texture on this. You want to use a gradient from white to black, and you want to put transparency up to 1. Use an RGB intensity mask and bring your ambient, diffuse, and specular down to 0. Make sure the overall blending is all the way up. And you also may want to use an RGB intensity mask on the overall blending as well. This is going to put a transparency map on the edge of this so that we don't notice the edges so much. It'll blend them away. They'll become transparent the further they get towards the edge. So you won't notice these hard seams. So this is our final head. We've done a symmetry on the first eye patch so that we have the second eye patch, and we put a couple of eyeballs in there so we can make sure everything looks okay. Now if we preview that, here we can see that the transparency map is looking pretty good. It's blending out the hard edges around the eyes. We can put ears on him later. Right now we're going to go and look at the next method for making a head. The second method we're going to look at is called the North and South Poles method. Here's an example of a head for the character Pam, which was done using this method. If we select it, you can see that I have a grid on here, and you can see how the eyes and the mouth, the points are being pulled back to create those indentions. Also, if we go to Setup, Show Icons, we can see the edge flags for this object. The U runs down along the back, and the V is at the top and bottom poles. Now, if we try to make this head from scratch, it's going to be kind of difficult. So we're going to use a deformation plugin called Shrink Wrap to get started. So rather from trying to model the head from scratch, we'll sculpt a rough head from metal balls or patch or NURB spheres, and then convert them to a single polygon mesh. Here we have a metal ball head. You can see it's got quite a few polygons. We've done a convert to polygon on it. And I want to do a reduction of the polygon, so I'm going to do an effect GC polygon reduction. I'm going to bring that to around 50% and say OK. Now you can see that the polygons are much reduced and it's going to be a little easier to work with for the shrink wrap. Here we have a different head that we've created from patch spheres. It's made from a bunch of different spheres that I've just scaled and pulled points on and moved to different areas. Now what you can do with this is you can do an effect merge on it, or you can do a GC merge, which is new in Soft 3.8, and that'll create a single polygon mesh that we can use in the shrink wrap. In order to use GC merge, you're going to have to do an effect convert on each of the patches here in order to convert them to polygons before you do the merge. So now we're going to merge the head. You can see I've already converted these to individual polygons, and then I'll do an effect GC merge. You want to check the first two boxes. Now that this is merged into a single object, we can do the shrink wrap. Now we're ready to do the shrink wrap. Here we have the polygon head. I've actually added a neck to it, and what you need to do a shrink wrap is you need the target mesh, which is the head, an outer wrapper model, which is going to be entirely outside of the head, and an inner wrapper model, which is going to be entirely inside the head. Now the outer wrapper model and the inner wrapper model, they have to be the same objects. They should be the same kind of surface and the same number of points. It's best to just do the outer wrapper model, duplicate it, and scale it down to make the inner wrapper model. In this case, you also may want to add some points on the areas of highest detail. I've gotten a sphere here, and I've added some points to the front of it. I also opened up the bottom so that I could do the neck properly. Then I duplicated that sphere and just scaled it down so it was totally inside of the head. With these three things now, I can do the shrink wrap. So to do a shrink wrap, you want to go to Deformation, Shrink Wrap. You want to shrink wrap to a factor of 1, that's all the way to the surface. And what's going to happen is the points from the outer wrapper are going to go towards the points of the inner wrapper until they meet on the surface, effectively shrink wrapping the surface. It asks you to click on the target mesh, the outer wrapper model, and then the inner wrapper model. The results aren't perfect, but it does give you something to start with. To do the next step, we're going to extract curves from 1/2 of this face. To extract curves from the head, you want to select the head and go to Draw, Extract. Click on the head, and you want to do probably every 1/2 degree. So this is what you get when you're done extracting the curves. You get 1/2 of the face with an even number of curves. Another way of starting this method is to just shrink wrap the curves themselves. Here I've got two sets of curves, an outer wrapper one and an inner one. These are cardinal curves, but you can use cardinal or NURBS. I'm going to take the target mesh and do a deformation, and in this time I'm going to do HRC shrink wrap because they're hierarchies. Same shrink wrap factors, say OK, click the target mesh, click click the top of each of the hierarchies, and it shrinks the curves over the face. Once you have curves for one half the face, you want to skin them with modeling relation turned on. So we're going to skin these. Probably the top view is the easiest. And we're going to use a cubic NURB surface. Putting modeling relation on will allow us to model using the curves rather than the points on the surface, which in NURBS it's difficult because the points don't sit on the surface. To inverse the surface when you're using modeling relation doesn't really work. You have to select the curves and inverse them. Otherwise it'll just keep inversing back again. Now the next thing you want to do is you want to duplicate instance this object and scale the instance -1 in X. This will give you another face, which is a mirror image, and it will update when you start pulling points on the splines on one side. You'll see it updating on the other. At this point you may want to set up an interactive reference guide with the camera. Here I've got the camera placed on a 90-degree arc. It goes from a timing of 1 to 13, so that at frame 1 it's looking from the side, at frame 7 it's looking at a 3/4 view or 45-degree angle, and at frame 13 it's looking from the front. I also have 3 squares which I've placed a texture map of my character from the front, 3/4 and side view, and I've got them set with a node visibility for frame 13, then frame 7 the 3/4 view reveals itself, and then at frame 1 the side view reveals itself. Now with these pictures you want to make sure in Photoshop that they line up through the eyes and through the nose and through the chin, and that they're all in the same aspect ratio of a square. That way when you bring them in here and put them on as a texture map on a square, they'll all line up together. You want to make their centers right around the 0, 0, 0 point. I've also got set up here a clipping plane on the camera, and this is an interactive clipping plane. I've got it set so that all I'm going to see at this time is one of these curves. No matter where I'm at, I'm pretty much only seeing one curve for each of the angles. Now I can adjust that clipping plane if I want to see more or less of the head by selecting this square and moving it in Z. Moving it one way increases the clipping plane, and moving it in the other decreases it. So it doesn't really matter which side I'm looking at. I can see more or less of my head by moving this square. And what I have here is an expression set up to the camera's near and far plane. So if you go into motion and I select the camera and go to expressions edit, you can see in the expressions editor that I have the camera's near plane set up to this object which I call cam clip, and its explicit translation in Z. In this case I'm offsetting it by 4, and you're either going to put a plus or minus to go in one direction or the other. Now if I go to the next, you'll see that this is the far plane for the camera, CM far, and it's to the same square, explicit translation in Z, is actually a plus instead of a minus. And what this effectively does is when I'm moving this backwards and forwards in Z, it's moving those planes in opposite directions to get either thinner or wider, depending on how much of the face I want to see. Now you're going to want to start pulling points on the curves, but you'll notice a problem when we start to do this. As soon as I start to pull a point, I lose the picture that I'm using as a texture map with Enable Hardware Texture on. Now what I need to do is I need to draw another guide which will help me out with that. I'll do a draw curve, and I'm going to use a NURBS freeform. I'm going to use my picture as a guide here. And then what I'm going to get is a primitive null, and I'm going to make it parent to all the curves that I just drew. And I'm going to color those a certain color so that I can recognize them. Now when I go back and start pulling points, you'll notice though the picture goes away, my guide still stays, and I can use that in addition to the picture. One other thing you might want to do before you get started pulling points is you might want to adjust the selectability of the objects that you don't want to be selecting in the three views. In other words, the actual surface, the instance, and these guides that we've drawn. So what you can do is you can select these in multi-mode and then go to Select, Selectability, and toggle their selection. That way when you're over here trying to select curves, you won't ever select these surfaces or guides. One thing that you might want to keep in mind before you start modeling this way is that the points have to keep a smooth continuity across the surface in order for it to look right. So you may want to tag the points for the back of the eye and the back of the mouth and any other places which are going to be important to keep lined up. After modeling for a while, you're going to get a head which looks something like this. Now notice how the points are being pulled back to create the indentions for the mouth and for the eyes. These are the areas of the highest detail, so they have to have the most number of points. It's going to be difficult to smooth some of these points out in other areas like the cheek and around the nose, but just try to move them so that they're evenly spaced, and then we'll use magnet to make sure that they don't have striations later on. At some point you're going to want to delete the original curves and do the final adjustments on the face itself. You should also remove the selectability from it. Then if you're not using a NURBS surface, you should convert it to a NURBS surface. And in this case, I'm also going to use NURBS weighting to do some of the final adjustments on the face before we merge it. Here you can see I've tagged a point in the nostril area, and I'm going to use Edit NURBS Weight Tagged Points to adjust how that nostril is being pulled out. Lastly, before we merge this with the other half of the face, you may want to remove any striations that you might have in areas where points are bunching up, around the side of the mouth on the cheek or around the side of the eyes. To do this, we can select this object, do a duplicate immediate. Then with the duplicated object in wireframe mode, we're going to go to Edit Delete Point, and we're going to delete a row of points. Then we're going to add the points back again. We might also want to do that in the other direction. Then you want to go and turn magnet on. Magnet on point. Say OK. Select the original surface, and using magnet and the M key, just move the points and they'll pop into place just in that area. We'll delete the other one. And take a look at it. And you can see that the striations are pretty much removed now. Okay, the very last thing we want to do is merge this one half of the face with the other half of the face. To get the other half of the face, do an effect symmetry. Do it in the x equals 0. And then we're going to have to turn on show edge flag so that we can see the U and the V's of this surface. Now we can see that the U on the one half is going from the bottom to the top, and the V is going from the mid part of the face outwards. On the other one, the V is going in the opposite direction, from the mid side outwards, and the U is on the opposite side as well. It's starting at the top and going down. So on the second one, we're going to do the same thing we did before. We're going to go to Effect Curve Controls. We're going to inverse the V. That inverses the surface, so we'll do an effect inverse. That actually inverses the U, which now places it so that it's in the correct directions. The U is starting at the bottom on both of them and going up, and the V is going in the same direction in this case, from the outside to the inside on one side and from the inside to the outside on the other side. So now we can merge these two surfaces. To merge them, we're going to move the second surface in X a little bit out so we can click on the open edges here. Then we're going to select the original surface, and we're going to go to a Draw, Merge Surfaces. You want to click the open edges of each of the surfaces. And you want to choose a blending type. In this case, we're going to join second to the first. So the second one, which we moved out, is going to pop back into place. Then we'll hide our two original surfaces. And sometimes you might see a little line down the middle of the face. So you may want to go ahead and do an edit delete point of that center line. And that will get rid of any sort of noticeable line down the center of the face. And that's the final result for this method of modeling. If you want to do the back of the head, you should extract the curves from the edges here and then skin around a back of the head and merge it in the same way that we've merged these ones. The third surface method we're going to look at is called the segmented surface method. Here we have the face for the character Harry. Now you can see that this face is made up of 3 grids. They're not actually merged because we want to open them up around the eyes and the mouth, which are traditionally problem areas. In this case, we're opening them in those areas but we're closing them using magnet in the other areas of the cheeks and the bridge of the nose. To do this, you're going to need to use cardinal patches, or with the new NURBS continuity plugin, you could use NURBS. As you can see when we remove the grids, the seams hide pretty well. This is one of my favorite methods, and I think you're going to find it useful for modeling several different kinds of things. To begin this method, we're going to use shrink wrap again. In this case, we're going to shrink wrap 3 grids on a polygon head. We have 3 grids here, and if I look at them, I have 181 points in the U, 61 in the V, and these are Bezier grids. You want a lot of points to get as much detail as possible, and then we're going to extract curves from those, so we're not going to use all of those points. And then also, you want to use a surface which is going to give you a lot of detail, which is cardinal, Bezier, or quadratic NURBS. Cubic and B-spline are a little bit too smooth and they don't shrink wrap as well. So to shrink wrap these grids, I'm going to duplicate them, make another set of grids, scale them down so that they're inside of the head. I also, on the original grids here, used a lattice to deform them a little bit so that they're not quite flat, but they're a little bit round. They follow the contour of the head a little bit. They're going to shrink wrap better that way. So here I have 3 grids inside the head and 3 grids outside my polygon head. Now you want to try to line up the edges of these grids with the eyes and the mouth, because that's where you're going to be separating them. Then you just want to do a deformation shrink wrap for each of the sets of grids on the head. So I'm going to go to Model, Deformation Shrink Wrap. I'm going to click on the head, and I'm going to do the first 2 grids. Okay, so you can see the first 2 grids were the bottom of the head. Here is what I ended up with from my shrink wrap. Now what I want to do now is I want to extract a certain number of curves out of this. Now I've converted these surfaces from Bezier to NURBS in order to make the extraction a little easier. Then I'll do a Draw Extract. I'm going to extract these curves in the U direction in even increments, starting at 0 and then adding 0.02 in this case, 0.04, and so on until I get half the face done, or I could do the whole face. After I do that, I'm going to skin those curves, and I'll have a less dense face from which to pull points on. After I extracted my curves, I did an effect convert on them so that they would be cardinal curves, because I wanted to use a cardinal surface. Then I skinned them with modeling relation turned on. At this point, I want to go in and select the original curves that I skinned from, and I'm going to move points to open up the eyes and the mouth. With this kind of surface, this is relatively easy to do. So here's the face after we've been modeling a little while. If you've been using lattices and you've been using proportional modeling, the seams are going to come apart a little bit. After you've freeze the modeling relation or delete the curves, just go back in on the surface itself and magnet those back together again. And it'll close that right back up. Now this surface is a cardinal surface, and it works pretty good. Most of the seams are hidden, but you can't do reparameterization like you can with NURBS. So you may want to convert these to NURBS surfaces, but you'll find that when you do that, you end up seeing the seams because of the way NURBS don't have phantom points which overlap the surface, so you can't really magnet them very well. There is a new plugin you can use though, and it's called the NURBS Continuity plugin. You select the three surfaces, and then you go to Model, Deformation, NCF. Here we're using a tolerance of 0.009. This is going to keep it from closing the eyes and mouth, which we don't want to happen. If you put a higher tolerance number, you'll see the eyes and mouth will start to close. Now if you look at the surface, the seams are pretty well hidden. This is a motion effect and will update as you animate. This concludes the third method of making a face using the segmented surface method. Just keep in mind when you're modeling this way that you should always have the same number of subdivisions across the seams so that you can magnet the points together, and all of the surfaces should be of the same type, either cardinal or NURBS. Later on, we'll see how to put skeletons in here so you can animate this without the seams coming apart. Here you can see the finished head for the character Harry. We've added ears and a top and a back of the head, as well as some eyeballs. Now if we look at these different pieces, we can see that the back of the head is a semi-revolve type of shape. It connects at the edges of the face. I'm actually overlapping these surfaces a little bit and using a gradient transparency map like I did on the eye patches for the Igor character. If you look at the top of the head, it's a simple revolve. The ears are also a revolve. I've just used proportional mode to pull points and model out the shape. If I do a preview of this, you can see that the seams are not too noticeable around the ear or along the edge of the face or along the top. I've modeled out a little bit of an edge for the hair with the geometry, but most of the hair will be a texture map which we'll put on later. Now again, the thing to remember when you're modeling this way in pieces is to make sure that there's continuity by making the point structure the same across the patches. To model out an eyeball, it's pretty easy. At this point you may want to add a row of points. You can then tag that row of points and scale it down a little bit to create a little highlight where the edge of the colored part of your eye is going to be. You can then use a texture map and line it up accordingly. Another way you could do this would be to convert that to a NURBS and then do a cut on it so that you have two pieces, and then you could put just the color texture map on the one piece. You would want to make the smaller inner part of the eye child to the outer part of the eye. Here's the Pam character again, and you can see her hair is pretty simple. These are just patch grids, or in some cases they're extrusions which have been deformed along a curve. She also has some eyelashes. Using magnet, I drew a curve along the eyelid. Then I duplicated that curve and skinned between it to create the eyelash. In this section, we're going to look at how to model the characters' bodies. As in the last section, you're going to want to keep in mind the continuity between UV surfaces in order to hide the seams. In order to do this, you should make sure that the surfaces have the same number of points. They should also be of the same type, and the joints in the skeleton should cross the seams. This will keep the seams from coming apart when you animate it later on. Now let's look at some of the characters that we're going to be showing in this section. Here is Igor the wrestler. You can see where his seams are here. Notice how the bottom of his trunks are hiding the leg seams. Here's the character Pam, which was done with the segmented surface method. Here's where the seams are on her character. Lastly, here's the character Harry. He's wearing clothes, so the seams aren't such a big issue. But one thing that you have to be aware of is that the bones should cross the seams. So keep this in mind when you're making your characters. This is the torso for Igor the wrestler. Basically what I've done here is I've shrink wrapped a sphere over another object which I created out of patch spheres and then did an effect merge on. You can see that this is made out of all individual spheres, and when it shrink wraps, it turns out pretty well. Now the neck is another piece entirely. Because of the way the head is, with the poles in the mouth on the front and the back, you can't really do a merge between the head and the torso, which has poles on the top and the bottom. So what I had to do was create a separate surface which would line up enough so you don't notice the seams. To do this, I did a draw extract on the body itself. That would get me a curve which is sitting right on the surface. I then took this curve, scaled it in Y until it was flat, and did a surface deformation on a duplicated one on the head. Scaling it and moving it into place, I then duplicated that and made several in-between curves. Then I can do a skin by going to Surface Skin, and you can see that it skins pretty much right to the surface of each of the head and the torso. The next torso I want to show you is for the character Harry. Here you can see we've got his jacket, belt, shirt. Now if we go look at how these things are constructed, you can see that the geometry is pretty simple again. You want to try and save on file size by making your geometry simple. Things like folds and stuff like that you can put in with texture maps. Now here we've got the jacket itself, which is a simple revolve type of shape, which has been modeled a little bit afterwards. There's a little lip on the bottom here. Now the main thing when you're modeling clothes, you have to worry about seams less because clothes naturally have seams. However, what you do have to worry about is overlapping of clothes and intersecting of clothes when it starts to deform. So in this case, I've got a shirt here, and if I look at it, its point structure is very similar to the point structure of the jacket. If it was very different, when the chest starts deforming, they'd be coming through each other. So to minimize that, I've made the point structure very similar, and also I didn't model the entire shirt. I just modeled the part that you would see in the front. If you look at the two parts of the shirt, you'll see that the top part is a revolve and the front is just a patch. Now they're both cardinal patches as far as the surface goes, and I magneted the points together, but because one's a revolve and one's a patch, you still see a little bit of a seam in shaded view. But when you put the texture map for cloth on there, that pretty much goes away. Lastly, what I've done also on the shirt and the jacket is I've made a bunch of clusters on these. If I go to motion and go into cluster list, you'll see that I've made a cluster for each of the buttons. And then I just did a constraint object to cluster for the buttons so that they would stay on both the shirt and the jacket when they deform. Later on, when you put the skeleton in, you're also going to want to constrain all of these buttons in orientation to an object that moves with the chest. Otherwise, they would always be facing forward, and you want them to turn whenever the chest turns. Lastly, for the character Pam, I used the segmented surface method that I showed earlier. If you look at this, you can see that it's made up of several different pieces. The seams are being hidden because the pieces have the same number of points and they've been magneted together. You're going to want to use a combination of shrink wrapping and skinning to do this. What you should do is make a polygon character out of either spheres or metaballs. And in this case, you can shrink wrap the chest area. Down here you can shrink wrap a revolve. You also have a revolve up here at the neck that you can shrink wrap. For this side piece, which connects the front to the back, you can just draw a curve with magnet on the edges of the front piece and then duplicate that and skin it to the back piece. All of this fits together fine because they all have the same number of points. You have to count the points. For instance, for this revolve, in order to know how many points I would need, I had to count. After I made the top part, I counted the points, which encompass all of the pieces for the top part. This is a good way of modeling if you're using patches or NURBS. The only thing you have to think about is you want to make sure that the bones are going to cross the seams. Now we're going to talk about joining an arm to a torso. I mentioned in the first part of this video that it's very difficult, if not impossible, to make a whole torso and arms out of one single piece with patches or NURBS. So we're going to have to do some kind of a skin or something to make a separate piece that looks like it's joined but really isn't. And as long as we weight the points right, it shouldn't come apart. He has a polygon arm. I created this arm out of spheres and just merged them all together to make a polygon object. Then I'm going to shrink wrap over it a series of curves so that they get this same sort of geometry for the curves. What you want to do is just get a bunch of circles, duplicate them, put them outside the surface, then put them all under a null, duplicate that and scale it down so it's inside the surface, and then do an HRC shrink wrap for the two hierarchies. Now what I need to skin this to the torso is I need a curve on the torso. Now if we look at the surface of the torso, the points don't go in such a way that we can really extract a circular curve that we can use for skinning to these other curves here. So what we have to do is draw project on NURBS surface a circle, and then we'll extract it and we'll skin that with the rest of these curves. Now I want to project a circle onto the surface of this torso. I got a circle, rotated it in Y 90 degrees, froze it and moved it out where I think it should be projected from in the x-axis. At this point, you want to turn modeling relation on. because that way we can move the circle around if we want to adjust where the curve is sitting on the surface. Then you're going to select the torso, go to Draw, Project on NURB Surface, and click on the circle. You want to make it project in the x-axis. You can do perspective, which does it according to a point. It'll make one side larger than the other, but we don't really need that. We want both sides to be the same. Actually, we're really only concerned about one side. We'll do a preview of this, and you should be able to see some purple lines which show you how that curve is going on that surface. We just want the one on the one side, so I'm going to turn off projection 1. You may also want to go into sampling and set this down a little bit. I'm going to set it down to 3 and say OK. When you use modeling relation, it's going to create a whole other torso. I'll just hide the original one. At this point, we want to extract the curve. Before you extract the curve, though, you should go into Draw, Curve, NURBS Curve Setup, and you should set the error tolerance up a little bit. Otherwise, you're going to have a zillion points on the curve, and it's going to make a very heavy arm. I would set it to somewhere around 0.4. Say OK, and then do the Draw, Extract. Click on the surface. You want Trim and Projected Curves, Projected 1. Extract it. Now if we select that, we can see that we have a curve which is sitting on the surface, and it looks pretty good. The last thing we want to do before we skin these with the other curves is make sure that the edge flags line up. We don't want any twisting going from these. So if I select this curve, I can see that the U is going from this point here clockwise, and on the other curves the U is going from down here and it's going counterclockwise. So since I only have one curve for the projected curve, I'm going to change that one. Go to Effect Curve Controls. I first want to inverse the U, and then I want to shift the U into place. Once they're both the same, then I can skin them. So here's my skinned arm. To make the seam as least noticeable as possible, you want to try to project your curve in an area which has a natural sort of indentation to it. You also want to make sure that you're projecting into an area where you can cross a bone across so that we can keep this seam from coming apart. In this case, the bone coming from the collarbone down to the shoulder is going to cross this seam. The last thing we want to do with the Igor character is just symmetry this arm to the other side. So that we have two arms. To attach an arm to the character Harry, we're going to use a similar method but not quite the same. We're going to deform a curve onto the jacket surface and skin off of that with these other curves that we've already made here. So what I want you to do is get a primitive circle, rotate it 90 degrees in X, then freeze it. Make sure it's scaled somewhat to the right size, and then you want to do a deformation by surface node create. Click on the jacket. Now it's going to get all scaled out again. What you want to do is you want to scale it in X and scale it in Z. And then move it in X and Z till it's in the correct place. You may also have to translate it in Y a little bit so that it's sitting right on the surface. Lastly, I can skin these curves. To get my arm. You can then do symmetry to get the other arm. For the Pam character, we can do the arm in the exact same way. The only difference is that we're going to need to do a magnet and draw the curve that we're going to be skinning to. Make sure you close that curve, and then make sure all the other curves in the arm have the same number of points. Then you can skin them, and it should have a seamless connection. Of the three characters, the character Igor has the simplest legs. In this case, it's just a simple extrusion or skin, and we're not really concerned too much about the seams where the leg meets the torso. The reason is this seam is going to line up with his wrestling trunks, which are going to be a texture map. Here you can see I've used a simple texture map for the trunks, which hides the seams for the legs, and there's also texture maps for the boots as well. As always, with any body parts that are going to bend, you should pay close attention to the joint area as far as point structure goes. It should be going in the right direction, and there should be some points around the part that is going to bend so it doesn't collapse too much. You should also look at this when you're doing arms. Here you can see Harry's legs. In this case, the legs are separate from the feet. And if we look more closely at this, the two pieces of the legs are actually separate from each other. Here you can see one of the legs. If we look at that more closely, you can see that it appears to be closed most of the way until it reaches up here and then it opens up. Now this is actually an open surface. It only appears to be closed, and that way you can open it up when it gets up towards the midsection here. And you can use that to combine with the other piece so they look like two seamless pieces. Basically, you want to get a circle and open it, or you want to draw a circle and don't close it. You want to overlap the points so that you can grab them and open them up. Now you want them to remain appearing to be closed all the way up until they get to the torso area. Then you want them to open up. Then you're going to skin these curves. And I suggest doing it with modeling relation so you can adjust it afterwards and then freeze the modeling relation off of it. Lastly, you're going to want to do an effect symmetry so that you have the same thing on both sides. And then you can magnet the points together to make sure the two pieces come together correctly. As you can see, the feet are separate pieces from the legs in this case because of the clothes. One thing I want you to note about the feet though, some people do their feet straight across with the subdivision straight across because it's easier to do the bottom of the foot. But that won't bend correctly. The points won't be in the right direction to bend at the instep and to bend at the ankle. The best way to model a foot is to have the subdivisions go out to the end of the toe like I've done here. You can either stop it at the end of the toe or you can pull it down like I've done. In this case, you have subdivisions in the correct places for the bending at the instep and at the ankle. You can make a separate piece for the bottom of the foot, but make sure that you make the subdivisions similar so that it will bend in the same way as the foot. With the Pam character, if I wanted to have a seamless connection between the torso and the legs, I'd probably want to use the same method as I used with the character Harry. In this case, you can see it's the same open surface that connects in the middle, and it also connects at the torso as well. I also did separate feet with this one so I could use a closed surface, and they go straight out to the toe. Now if you were going to put something like a belt in here, like we have here, then you could use a different method. In this case, the belt is going to cover up a seam at the midsection, and here I could use a single surface which goes all the way from one foot up, around, and down to the other foot. Now you would notice a seam in the middle here because these wouldn't line up quite right with the torso. But with the belt there, you wouldn't notice it at all, and you could use a single object. The best way to start this method would be to shrink wrap some curves over a polygon leg, then skin them up halfway, symmetry it, and then merge it. The first hand we're going to look at is for Igor the wrestler. It's the simplest hand, and it's composed of separate pieces. There's not much concern about seams because he's wearing weightlifting gloves. Let's take a look at that. Here you can see a preview of the hand, and you can see that I'm softening the seams in the knuckle area by using a gradient transparency map. In hardware view, you can see the different pieces of the hand. The fingernails are just spheres scaled down and given a higher specular. For the thumb, we just projected a curve onto the nerve surface of the arm and skinned off of that. Next, we want to look at a preview of the hand for the character Harry. This is a little more realistic hand and a little more difficult to model than the last one. Let's go look and see how this was done. On this hand, the fingers are connecting after the knuckles. This creates a nice blend by magneting the points. The thumb was created by surface deforming a circle onto the hand and then skinning off of it. We're hiding the seam by putting a gradient transparency map on. To begin this hand, get a primitive cardinal circle and then add 2 points. Delete the middle point, duplicate the circle, and on the second one, add 2 more points. Delete the middle point, and then duplicate the circle again. Lastly, do an effect symmetry in X of the original circle. So you should have 4 circles sitting right beside each other. The 2 in the middle have 4 extra points, and the 2 on the ends just have 2. Then turn magnet on and draw a cardinal curve. When you get to the end, just close it. So now I have a single curve which goes in the same shape as my circles. At this point, you're going to want to duplicate the circles going in one direction to create the fingers, and then duplicate the other piece going in the other direction and scale the middle points here in Y in tag mode to open that up. So you can see that these curves are gradually opening up as they go back towards the palm. After you skin the fingers in the palm, you're going to want to magnet the phantom points over each other. You may also want to turn on Show Modified Area. That's going to show you the area that's being changed when you're pulling points whenever you're doing magneting. Magneting the points is going to smooth out the connection between the fingers and the palm. The last hand I want to show you is for the character Pam. It's done with the same segmented surface method that we used on her body. As you can see, this hand is made up of many pieces. Most of these are either skinned or shrink wrapped. If we look at it in another view, you can see all the pieces that make up this hand. This is a pretty difficult hand to do. You probably want to do a polygon hand and then try to work on top of that. You're going to do a lot of magneting of points. The first thing I want to show you is how you can set up texture mapping on a UV surface. Here I've got 3 heads for the character Pam, and I want to put a texture on these to use as a guide so I can see how the texture is going to sit on the surface. Now you always want to use UV textures, not the projected methods, whenever you're doing a character. The reason for this is UV locks to the points, and when you deform the surface of the character, the texture won't slide over the surface. Now, the UV texture is going to be according to the UV surface. So by putting a grid like this on here, I've just made a simple grid with some colors and some numbers on it so I can tell what's what. Before you make the guide though in Paint, you should first make sure the texture map is on the best possible way on your surface. To do this, you have to be using NURBS, and you can use Effect Reparameterization, and you have several choices. Most NURB surfaces start out as non-uniform unless you set them to uniform when you're skinning them. The other ones you have is chord length, centripetal, and uniform. The last one I have here I haven't done yet, and I'll do that one as centripetal. You can see how the texture changed on it. The first one on the left here is uniform. The middle one is chord length, and the third one is centripetal. You can see that they all are a little different in the way that they adjust the texture according to the subdivisions that you have on your head. In this case, I believe the uniform one has the most even subdivisions and will make the best texture. You should set this to the parameterization that you want it to be before you go into Paint and draw on the surface. Then I'm going to go into Paint, and I can see how this grid sits on the surface of my character. At this point I could choose a color that's not in my grid, and I can paint directly on the character. This is one of the good things about the Softimage paint editor, is that you can draw directly on your surface. Now it used to be you could only do this on a polygon character that you converted to UVs, but in this case in 3.8 you can now draw directly on surfaces other than polygons. So what you can do is draw a guide for where all the parts on your character are supposed to be. You can then use this guide in another paint editor like Photoshop At this point, you want to open your guide in Photoshop and do all your airbrushing and compositing on top of it. That way, when you go back into Softimage, everything will line up correctly. Now we want to talk a little bit more in detail about the kind of texture maps that you want to put on your characters. There's three main maps we're going to be looking at: a color map, a bump map, and a specular map. Here we have the character Harry. Before we go in and look at the texture maps that I've applied to his face, let's go preview it. In this preview, we can see all of the three textures working together to create a realistic surface. The color map is the main map. It's what's creating the surface changes in color on the surface. The bump map was made from the color map and is producing the bumps for the surface texture. It's what's giving the skin a little bumpy texture and making the eyebrows stick out a little bit. The specular map is what's making certain areas shiny on the face and other areas less shiny. You can see some highlights on his forehead, on the nose, the chin, and the cheekbone. This is all being created because of the specular. Here you can see the main color map in Photoshop. You can also see that in the layers here we have the original guide that we drew using the grid. And you can also see that there's a lot of layers to this. For this particular map, we cut this into three sections to apply to the three sections of the face of our model. Back inside of Softimage, let's go look at how I've applied the three textures to this particular part of the face. Inside the texture editor, you can see that the first map we have is the main color map. We're placing this on as a UV texture, so it's locked to the points, and we've got overall blending all the way up in the ambient and the diffuse. I'm also putting a little bit of roughness on here. The next map is the bump map. Now you may notice that I've inversed the eyebrows on this bump map, and I've also got some skin texture in here as well. This is going to give some bumpiness to the skin and make the eyebrows stick out a little bit. I'm also placing this on as a UV texture. I've got the overall blending all the way down, but I've got the roughness pulled up. Actually, I'm using negative 2.127 right here. The overall blending is pulled all the way down in order to just facilitate the bump and nothing else. The next map is the specular map. In this case, I've got the overall blending all the way up, but it's only in the specular. I've got the RGB intensity mask on in order to make only the light areas shiny, and as the areas get darker, they become less shiny. If we preview this, we can see all the maps. Previewed this close, you can see all the maps at work. The bump map is creating the surface texture for the skin, while these highlights on the forehead are being created by the specular map. The color map is creating everything else. You should do all of these three maps for all your main textures. Here we've got the wraparound part for the back of the head. And as you can see, we've got all three textures on that as well. One additional one that we have on this is a transparency map with transparency turned all the way up. It's a gradient map with the overall blending all the way up, ambient, diffuse, and specular all the way down, and an RGB intensity mask. If we preview this, and that's what's creating this soft edge along the left side here, which is where it connects to the face. Now we want to look at some other mapping types. The first type we're going to look at is something called displacement maps. You have to have the extreme version of Softimage with Mental Ray to use these. The geometry I have for the top of the head you can see is completely smooth. If I go into the texture editor, however, you can see I've got a hair texture on here with displacement map turned on and roughness turned up. If we preview that, you can see that it's actually moving points in the geometry to create a bumpiness to the hair. You can see this in the shadow as well as on the hair itself. We've talked about using transparency maps with a gradient on two surfaces that slightly overlap in order to soften the blending of those two surfaces. Now, another use of transparency maps is to make complex edges that would be difficult to make with geometry. In this case, I have the Pam character, and I've got a hair piece that I want to create bangs with, but I don't want to do that with geometry. So I'm going to go to Texture, and you can see that I've placed a texture map on here with the transparency all the way up, overall blending all the way up, ambient diffuse and specular all the way down, and an alpha channel mask. If we go into Paint and turn on alpha only, we can see that there's an alpha channel mask which is going to mask out what area is going to be transparent, which is white, and what area is going to be opaque, which is black. And this is going to create the bangs for us. If we preview that, you can see that it does a pretty good job of creating bangs, complete with shadows being cast. There's one other kind of texture map that you might want to use, and that's a reflection map. You'll probably only use it on articles of clothing or an eyeball. Here I have an eyeball, and I'm going to go to Texture. In the texture editor, you can see this is the regular color map. Then I'm going to go to Next, and on here you can see that I have a non-ray traced reflection map. I've got the intensity at 0.76, which is pretty high, and I've got an RGB intensity mask on. So the lighter areas are going to show up. Then I'm going to go to Next again, and you can see here I've got a specular map with the specular turned all the way up. And it's just a dot. This is the very middle of the eye, the black part of the eye. I didn't want to highlight on that, so I placed the specular map to make all the rest of the eye get a highlight, except for that black area. If we go and preview this, you can see the reflection map around the outer edge. It gives it more of a realism. And also you can see that the black area does not have a highlight in it. That's being taken out by the specular map. Whenever you're building your characters, you're going to want to do it as efficiently as possible. One of the ways of doing that is to know when to use geometry and when to use texture maps. In this case, we have a minor item like this belt. Now, we could model out a belt, but that's going to take a long time and it's going to be heavy in geometry. Here I've just got a simple partial revolve, and I'm going to put a texture map on it to make it look like a belt. So let's see what this looks like when we preview it. Here we see the preview of the belt. As you can see, it looks pretty good. I haven't modeled anything out there. It's strictly a texture map with a transparency map to cut out the edge. You may also notice that I used texture maps for the folds in the shirt with bump map on, as well as for the pockets on the jackets. If we look at the texture for that, we can see that it's just a simple picture of a belt being projected from the front. I'm not going to get any deformation in that area, so projecting texture is fine for this particular instance. I'm also, if I go to the next one, you'll see that I have a transparency map, transparency all the way up, and it's cutting this white edge out. There are a couple minor elements on the face that you may want to use a texture map for as well. The eyelashes here, for instance, are just a simple skin with a transparency texture map on. Also, the teeth are the same way. Unless you're going to fly close into the mouth, Just using a simple skin with a texture map is fine for the teeth as well. As you can see here, when I remove the face, the teeth are just a simple skin. I put it on a curve and I put a texture of just some real teeth with a transparency map on. I've got two pieces here so that they can open and close. There may be times when using an animated texture sequence is going to be better than using a still texture map. You can achieve effects like blood flowing down the body or sweat, or in this case, tears. Here you can see I have an animated sequence that I've done in particles. It's some tears flowing down a face. In this case, I'm going to texture map this animated sequence onto the face of this character. In addition to my regular maps, I'm also going to put this animated sequence. You can see that I've put an RGB intensity mask on to mask out the black area, and I've pulled the overall blending down to make it a little bit transparent. I've also pulled the roughness up a little bit and the specular up. Let's preview that and see what it looks like. Here you can see the effect of the tears running down the face. If you had some metaball effects to actually have tears come off of the face, in addition to this, it would look pretty realistic. The last texture mapping technique I want to show you has to do with connecting skeletal bones to a texture map's blending. In this case, I have a joint in the middle of this character's body. I'm going to connect its rotation in Y to a texture map on the front of the torso. This texture map is going to change according to the bending of the torso. Let's see what that looks like before we go in and do it. Here we have the character with the texture map on the front of it. If I play this, you can see that there's a creasing going on in the middle of the torso. This is caused by the texture blending, not by the geometry. Now let's see how that is done. Here inside the texture editor, you can see that I have the texture for the cloth, the front of the shirt. This one has a crease in it. If I go to next, you can see this one doesn't have a crease in that same area. So it's the second one, the one on top, which I'm controlling the blending. If I pull my timeline, you can see the blending goes up and down according to how that bone, which is hooked to, is bending. Now the way that you do this, you have to go out and turn on matter mode in the schematic so that you can see your texture nodes. Then you're going to have to select the texture node itself. That's the only way you can put an expression on it. Then you go to Motion and go into the Expressions editor. Inside the Expressions editor, you're going to want to connect the object's 2D blending to the joint's rotation in Y. Now everything else in here is going to be different according to your own object. In this case, I'm starting it at 0.8, which means almost all the way up in blending. Plus or minus is going to change depending on which way you want it to go. And here I'm dividing it so I don't get such an extreme effect. You're going to have to play with this to get exactly what you want. If I go to Next, you can see that I also have one on the 2D roughness. Same sort of thing. I'm connecting it to the rotation in Y of the joint. I'm dividing it, and I'm starting at a particular number. This concludes Part 1, Realistic Modeling and Texture Mapping. Stay tuned for Part 2, Skeleton Rigging for a Realistic Human Character.